Hello, we are now taking up questions on parallelograms drawn between the same parallel lines and on same base. We had discussed with this theorem. Herein we'll be taking up questions based on the theorem. I write down a question first. In parallelogram ABCD, AB is equal to 10 centimeter. The altitudes corresponding to the sides AB and AD are respectively 7 centimeter and 8 centimeter. We have to find AD. Let us understand this problem within in a figure. Okay, I just can see that I had noted this in a small letter. Kindly ignore that, please. I'll draw a parallelogram ABCD. Let me name it as ABCD. Given the altitudes corresponding to the side AB, so I drop a perpendicular from this D to AB, that's given to be 7 centimeter, and from B to the side AD, so it might just look like this. These are imaginary altitudes, so please bear with it. It's M, this N, it says this is 8 centimeter. We have to find AD. Now how do we find area of a parallelogram? It is base into height. So the area of parallelogram ABCD can be calculated either as AB into DM, or it can also be calculated as, this is area of a parallelogram, or it can be calculated as AD with BN. So we can equate AD with DM with AD and BN. AB is given to be 10, we just substitute them. DM is 7, AD is to be calculated, BN is 8, that gives AD as 10 into 7 by 8. If we calculate, this gives out to be 8.75 centimeter. Let's move on with another question. The question reads as, the diagonals of a, I use short form, parallelogram ABCD intersect at O. A line through O meets AB in X and CD in Y. What do we have to show? We have to show that area of AXYD is equal to half of area of the parallelogram ABCD. Let us draw a figure for it that will help us understand it better. We draw a parallelogram A, B, C and D. The diagonals we have to draw intersect at O, it says, so we'll mark this point of intersection of the diagonals to be O. A line through O meets AB at X and CD at Y. So we have to make a line which passes through this point, and the point of intersection here is Y and this is X. So we have to prove that area of AXYD, this part, as half of ABCD. What we actually have to do is, what I do is, since the diagonals of the parallelogram divides it into two equal areas, two equal triangles, that makes them two equal areas. Therefore, area of ACD, area of ACD and area of ABC, they are equal. The diagonal, that is AC, dividing the parallelogram ABCD into two equal halves. So ACD area can be, I write, area of ACD can be represented as half the area of ABCD. Now look at triangles AOX, this one, I'll just highlight it. I'll change the color. In triangle AOX and triangle COY, what all do we have? We have two vertically opposite angles. I tell you, why are we finding the congruency of this triangle? So that we can equate the areas of these two triangles. Equal to COY, we can write here, they are vertically opposite angles. AO is equal to CO. Why? The diagonals of a parallelogram bisect each other, so O is the midpoint of OC. You can write diagonals of a parallelogram bisect each other. The third one, this angle will also be equal to this angle, thereby ASA we can use. Why? Because when CD is parallel to AB, these two become alternate interior angles. So I write angle OAX is equal to angle OCY. Here you can write alternate interior. Thereby applying ASA criteria and triangle AOX congruent to triangle COY. If these two triangles are congruent, area of these two will be equal. Area of triangle AOX will be equal to area of triangle COY. If we add the area AOYD, this portion, wait a minute, I'll just highlight it. If I can add this area to both these angles, let's see what we get. We get area of triangle AOX plus area of AOYD, and on the other side it is area of COY triangle plus area AOYD. Area of OX plus this gives us AXYD. Area AXYD. Sorry. I'll just clean it up. Let me erase this part, maybe because I dragged it more. Just excuse me for this. This gives us area of AXYD as area of, if I add this pink part to it, it becomes area of triangle ACD. Now look at this first equation we had noted. Triangle ACD was half of APCD. Now triangle ACD is equal to area AXYD. From these two equations we can say that area of AXYD is half of area ABCD. This one we were supposed to prove. I hope you followed it. Not that difficult as it seemed to us at the first go. Let's move on. We take a third question. I just quickly write down the question. P and Q are any 2 points. Any question becomes always easy if you get the figure correct and understand how your proof can be reached. Because there are few questions wherein directly you cannot reach your answer or the proof. Answer here I mean the proof. I have written certain part. I'll just draw it or show that area of triangle APB is equal to area of triangle BQC. Oh, here also I made a spell mistake. We have to draw a parallelogram which is A, B, C and D. We name it. P and Q are any points lying on the side CD. Let me mark this P, and AD any side, that is Q. So it is P, it's Q. Show that APB, that means I have to join, APB and then BQC. If you look at APB and the parallelogram ABCD are on the common base AB and between the same parallel lines CD and AB, that makes area of triangle APB as half the area ABCD. This is our first equation. Again look at triangle BQC, that is also drawn on the base BC between the two parallel lines AD and BC. At the same time ABCD is also can be seen as drawn on the side on the base BC. Therefore area of triangle BQC is half area ABCD. Both of them are equal to half area ABCD. Therefore from equation 1 and 2 you can write, from equation 1 and 2 we can say that area of APB is equal to area BQC. So we would have reached our proof. This I can write this as triangles. That was pretty simple. Thank you.